Hey, my name is Krus, and this is my favorite way to describe SDN by overlay. Imagine that you have a data center, and in that data center you have a bunch of hypervisors, so physical servers that have been virtualized with a hypervisor software. In such an environment, so these are three physical hosts now in my example, there is a software switch. This software switch is very simple, it's very rudimentary, so basically it's a patch panel in software. That's the only thing that the software switch does if we start without SDN. So this is a legacy data center. Okay, so on my hypervisors, I have a bunch of workloads. This might be VMs or containers. So something is running here. From a networking and security point of view, these are connected from the VNIC down to a port group that I have created in my environment, like this. So there's no SDN so far. From a management point of view, this is managed by vCenter, if this is a VMware environment. So the server teams, they are up here managing their environment. Okay. The network and security in the legacy data center is provided, if you don't have SDN, it's provided by the physical network. So the hypervisors are connected down to the physical network. The physical network is powered with the ability to perform routing, switching, load balancing, and firewalling. So in the traditional data center, we don't distinguish that this is software entities running. So we treat them from a networking and security point of view, we treat them the same. Basically, if something here is communicating, we will use a VLAN and just push that out. So if you take an example where this VM over here is talking to this VM over here, let's say, if they are on the same broadcast domain, then I need to stretch a switch, layer 2, between these two VMs in the physical network. If they are on different broadcast domains, then there has to be a firewall somewhere in the physical network and the ability to route between these two IP ranges. If there's a load balancer, that load balancer has to be somewhere, and if I need firewalling, there has to be firewall in between, right? The downside of this is that if we use all of these functions and we get them from down here, it's a little bit tricky, more tricky to automate this. So a driver towards SDN is automation. Automation. Because our users, let's say that our users over here, they would like to press something in some kind of cloud management portal, and what they press is a blueprint, sometimes referred to. And if I press on this blueprint, that means that something happens. I spin up a VM, a couple of VMs, or whatever I spin up, depending on what I pressed in my blueprint, what my blueprint meant. We would like to automate not only compute, but also storage, and not only compute and storage, but also networking and security. Because if you can get all of these entities software defined, then we can create them on the fly when there is a need. When someone presses something in a cloud management portal, I can create the compute with the storage, with the software installed, of course, with the network if I need to, and with a certain security posture. Okay, so imagine that we would like to install NSX into this. This means that I take NSX, which is the product from VMware, and then I upgrade my data center. So we have the ability to create networking and security. This means that when I upgrade my hosts with NSX, this means that I get what is referred to as a TAP, a tunnel endpoint. Tunnel endpoint is an IP address, and those IP addresses can communicate with each other, and what they communicate is using a tunnel protocol called GNV or VXLAN. GNV is the modern one, Generic Network Virtual Encapsulation, GNV. This means that if we take the same example, we have a VM over here talking to a VM over there. Instead of just pushing that out on a VLAN and let the physical network deal with the switching and the routing, load balancing and automation, firewalling, then instead we let the traffic go through the tunnel, like this instead. That means that by using the tunnel for the VM traffic, we then hide the behavior of the traffic between the VMs from the physical network. And that's the whole point. Because now I can create one network, I can create 10 networks, I can create 100 networks. I can create them, I can use them, I can throw them away, I can create them, I can copy them, reuse the same behavior, and then throw them away, or whatever is my use case, without really involving the physical network. The physical network only carries the traffic, being this high capacity, low latency, kind of highway, but it doesn't need to understand the logics that is going on the overlay, the SDN overlay. So in this picture here, this red rectangle here, this is my SDN. So in my SDN, in here, I can create any topology. I can create it once or 10 times or 100 times. I could use it for a year, for 30 seconds, or whatever is my use case. The only thing the physical network sees is 3 IP addresses communicating with each other. This brings us to the next use case, and the next use case we refer to as application continuity. Application continuity means that when I create something, a network with VMs, then my VMs should be able to consume this network and the security anywhere. So basically bring my own network. I'm a VM, I bring my own network, I bring my own security posture to wherever I am at this very moment. So imagine that I don't only have the DC number 1, maybe I have a DC number 2 and number 3 or whatever. Maybe I have AWS, maybe I have Azure, maybe I have something else over here in the future. Places that represent compute, places of compute. If I see the network and the security as a software thing provided from the hypervisor to my VMs running on that hypervisor, this means that I can actually bring my network and my security to wherever I am at this very moment. So it's kind of easy to just extend my SDN to include also external environments that maybe I don't manage myself. So it's someone else's infrastructure, but it's still my logical overlay running on someone else's infrastructure. Partly maybe it's mine, partly it's someone else. It's a little bit simplified picture, but you understand that what I'm getting at is that it's kind of easy. Just use layer 3 to have the ability to communicate within the SDN. I could basically create any topology that I like without using the physical fabric to anything more than just a bearer. So maybe I have a bunch of workloads over here connected to something. If I need routing when this guy is talking to this guy, it's taken care of by the SDN layer. We only consume the bandwidth of the fabric. The same goes with switching, load balancing. Security, however, that's actually maybe the third driver, security. When security was brought into VMware NSX product, it was a decision taken that this should be placed so that we actually have a firewall enforcement per workload. Let me show you how that looks like. Basically, the behavior and the position of the east-west distributed firewall for each workload is not within the SDN, it's up here, and it is a transparent firewall. Even though it is transparent, it's still stateful. It's a state-of-the-art layer 2, layer 3, layer 4 with up identification on layer 7, and with intrusion prevention and detection upcoming. So that means that one of the ways that you can look at SDN, if you have the possibility to do microsegmentation on an independent layer, is that you see the security as your third layer. Basically meaning you have the fabric down here, you have your SDN, where you create topologies for your virtual environment, and then we have the third layer, in a sense, up here, and this is your security layer. When you bring in security into the hypervisor environment, you have a lot of attributes that you can use, because the virtual environment knows a lot about the workloads running. So there is a bunch of different attributes that you can use, not only the source and destination IP. You can use the switch tag, you can use the security tag of the VM, you can use the name of the VM, you can use something that is known from VM tools or whatever is your use case. So from a logical point of view, this is how I think that you should see SDN. So I step into the picture. SDN, you may look at it as a 3-layer approach. The fabric, that's a highway, fast, stable, low latency, low jitter, but it doesn't contain the logic. The logic is in the next layer here. So it's the SDN. This is the topology layer where you create any topology for your workloads. But don't use that topology the old-fashioned kind of network-centric way. Put a security layer on top of that, and for instance use security tags, because if you are infrastructure independent in how you create your security layers, it's easier to get things working if you have a multi-cloud approach.